This video will let you know the origin of water. Although it makes up 70% of our planet's surface, scientists still don't all agree on where Earth's water actually comes from. Now, researchers claim to have found the origins of water in the earliest moments of the universe. According to scientists from the University of Portsmouth, water first formed in the debris of supernova explosions 100 to 200 million years after the Big Bang. These findings suggest that ingredients for life on Earth were in place billions of years earlier than previously thought. Using computer simulations, the researchers show that water would have formed when the very first stars in the universe died and collapsed into supernova. As the oxygen produced by these blasts cooled and mixed with the surrounding hydrogen, water was able to form in the clumps of material left behind. These dense, dusty cores are also the most likely origins of the materials that would go on to form the first planets. In their paper, Dr. Daniel Whelan and his co-authors write, besides revealing that a primary ingredient for life was already in place in the universe 100 to 200 million after the Big Bang, our simulations show that water was probably a key constituent for the first galaxies. Water, which has the chemical formula H2O, is made up of two ingredients, hydrogen and oxygen. Hydrogen was formed along with the other light elements such as helium and lithium in the first few minutes after the Big Bang as a sea of superheated particles cooled and clumped into atoms. However, oxygen atoms are so large that they can't be formed in this way. Instead, oxygen and other heavier elements had to be forged by the nuclear reactions created by stars. About 100 million years after the Big Bang, about 13.7 billion years ago, clouds of primordial hydrogen and helium came together under the force of gravity. As they grew denser, the pressure at the core eventually became so great that it kick-started nuclear fusion reactions which transformed the gas clouds into stars and brought the first light to the cosmos. Briefly reaching temperatures around 1,000,000 degrees Celsius, those explosions fused the raw material from hydrogen and helium atoms into larger molecules, including oxygen. In their paper published in Nature Astronomy, the researchers modeled what would have happened in the aftermath of two supernova explosions, one from a star 13 times the mass of the Sun and the second for a star 200 times the mass of the Sun. These simulations showed that the first and the second supernova produced 0.051 solar masses of oxygen and 55 solar masses of oxygen respectively. After the explosion, a cloud of hydrogen and oxygen is shot out into an enormous halo surrounding the remnants of the star, where they start to combine into water. At first, the low density of the halo means water levels stay fairly low, but as the halo starts to clump together under gravity, the water levels start to increase dramatically. After 30 to 90 million years, the smaller supernova produced the equivalent of 100 millionth to 1 millionth of a solar mass of water. The second explosion, meanwhile, produced 0.001 solar masses of water after just 3 million years. Water could survive the violent galaxy formation process, then it could have been one of the key components of the first galaxies. What makes this finding particularly interesting is that this could explain how water arrived on habitable planets such as Earth.